Sum 2. Given a collection of candidate numbers, candidates, and a target number target, find all unique combinations in candidates where the candidate number sum to target. Each number in candidates may only be used once in the combination. The solution must not contain duplicate combinations. For example, here we have candidates, and this is our target 8. So we choose the numbers that add up to 8, and these add up to 8, these add up to 8, these add up to 8. And this one we have this candidates list here, and we have to choose numbers that add up to uh, 5. So here we have these that add up to 5. This one is 5 by itself. So we can easily solve this by subtracting the number from target and then adding it to the array, to the yes, to the path that we're going to add to the, so this is a backtracking problem like the previous combination problem. So let's make candidates, and then dot sort, so we can sort the numbers out in order, and then oops, and then let's make a result equals to an empty list, and then let's take let's make a helper function for backtracking. Let's call it def backtrack, and then put start in, and then target, and then path. So that's what we're going to call inside our combination sum to method. So let's call it backtrack. Oops. Backtrack, and then let's put we're going to start from 0 so we can get an empty. And then start from 0, and then target, and then an empty list. So this path is basically an empty list. So now we're going to make our base function. So let's call base functions with base cases, man. So if target is equals to 0, let's take result dot so far whatever we have, let's take result dot append what are we going to add to it, path dot copy. If target is less than 0, meaning that it's negative, just return. Let's just skip it. Our recurse take it off. So if negative, so let's make our loop. So for I in range of start to the length of candidates, and then if, hold on, it normally starts with a, so for I in there, so if I is greater than start and candidates I is equals to the I on before it, so that will be candidates that I minus 1 So if that's it, let's continue to the next I. So now let's see, so now we get to do this. So now let's call on the let's call on it to so that we can. So if this applies it, then we'll go to the next loop, and hopefully that one does not apply to this, so we can call it the next one. So that will be back to right. Oof, back to right. Put let's start. That will be hold on, I plus one, and then put target. Just basic minus target minus candidates candidates I value, and then let's take path. So path will be plus candidate I. So we add that to path. We add the candidate value to path after subtracting it. So now that's basically it, I think. Hold on. Return result. So let's see. That should work perfectly. Let's see if it really does. And it's been accepted. So these are the candidates target, and these are the ones that add up to 8. Each one in these lists add up to 8. So our time and space complexity is times n. So I'll say I'll call it. Wait, hold on. Equals to O of 2k. No, 2 to the power of n is different different combinations. Wait. And hold on, plus k and hold on, n O of n plus n m times k. And is so I should put O of n is plus O F M times K is because and that's it for this problem. Let's summarize it to see if it's going to pass all cases. And it's been able to pass all cases.